All right, this is lesson 621, part 2. Just a couple more problems to go over here. Shouldn't take too long. We're modeling a function here. Actually, let's see a little more than that. We're modeling a linear function here. Carpenter charges a $45 fee plus $30 per hour for labor. Write an equation to model the total cost of the job. What graph models total cost? So we'll make a graph too. Let's just write a couple of values here so we can kind of get an idea of what's going on. This function, this relationship, depends on how many hours the carpenter works. So let's use H. Actually, let's use X for hours. So let's just define hours to be X. So let's say that X is the number of hours that the carpenter works. And then Y is the charge, how much the person is charged. That's the amount of money. So think about if the carpenter works 0 hours, how much would they get according to this? So in other words, a carpenter just comes and comes to fix something and notices that just one nail is all he needs, so he just pounds in a nail and doesn't really have any time. How much would that carpenter charge? So 0 hours is $45. And then the amount the carpenter gets goes up by $30 for each hour worked. So 45 plus 30 is 75, plus 30 is 105, plus 30 is 135, and so on. Now, if you think about our equations, if they're linear, they can look like this, where m is the slope, or how much it goes up for every time x goes up 1, what does y go up? And in this case, that amount is 30. So we're going to put 30 by the x. And then our y-intercept is the value, the output value when the input is 0. So if x is 0, what is y? In this case, it's the $45 fee. Okay? And then if we're going to make a graph of that, maybe we would do something like, we don't need any negative values, so we can just do a first quadrant graph. And I'm just going to choose values that I want here. Well, from our table, we saw that after 4 hours, we got up to $165. So let's just go up to about 5 hours. So we'll go from 0 to 5 hours. And at 5 hours, we're going to be a little over 200. So our y should end at maybe we go up by 10. We'll go up by 15 here. And we'll go a little over 200. Maybe we'll go to 225. All right. So there's my graph. And I know that when x is 0, y is 45, so that's about right there. And when x is 1, y is 75. When x is 2, y is 105. When x is 3, y is 135. When x is 4, y is 165. And if we did one more point, when x is 5, y would be 195. And then we could just draw a straight line through those. Now, if I draw a straight line, I'm just assuming that the carpenter would get paid for part of an hour as opposed to getting per hour wage. And so that's what that graph would look like. All right, here's a problem for you to try. Move this out of the way here. So a plumber charges a $65 fee for a repair plus $35 per hour. Write an equation to model the total cost Y of a repair that takes X hours. What graph models the total cost? Go ahead and try that, and you can check back with your answers. All right, this is what your answer should look like. And the rest of it we'll do in class. See you tomorrow.